Hello, my name is Josh Oberg, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Depression Identification Tool. This is the first tool in the Precision Conservation Siting Practices section of the ACPF Toolbox. This tool identifies depressions within a watershed by subtracting the original DEM from a filled DEM. This gives us a polygon output and a raster output. The polygon output can be symbolized to show the maximum depth of the depression or the percent hydric soils within a depression, which can provide valuable information for where water may pond. The depression raster can be valuable for seeing the depth of a depression. In ArcGIS Pro, we will open the catalog window on the right side of the screen if it isn't already open by clicking the catalog tab. Expand toolboxes and then expand our ACPF toolbox and expand Precision Conservation Practice Siting. Double-click the Depression Identification tool to open. This tool has 3 required inputs and many more optional ones. The first required input is our unfilled DEM, and that's our new DEM. We have that in our map, so we can choose it from the first dropdown. This will auto-populate with our second required input, our G-Surgo raster from our geodatabase. The last required input is our Z-factor, which, as we've done before, 0.01. Optionally, we can also include the field boundary feature class, the stream reach feature class without water bodies, and the water bodies feature class. If we do include the field boundary feature class, depressions will only be cited if they are centered within an agricultural field boundary. If we include the stream reach feature class, any depressions that intersect the stream reach will not be included. Including the water bodies will remove any depressions found that are centered in a water body. We will select all of these. Since these are all in the map, we will select the corresponding feature class for each. The next set of inputs, we do provide some default values. The first one is the minimum percent hydric. The mean percent hydric soils within each depression must be greater than a user specified value. We have a default of 60%. Then there's the minimum depth in centimeters of each depression, and we provide a default of 30 centimeters. And lastly, the minimum surface area in acres of the depression. We do 1/4 of an acre. For this run, we will use all these default values. This tool produces 2 outputs, one required and one optional. The required output is automatically populated and will be a depression polygon feature class. The second optional output is the depression raster. We will create this. You don't have to, but it is highly recommended as it can be very useful for visualizing the depth of a depression. We will click the folder and navigate to our file geodatabase. We will name this Depressions Raster. And then, as always, end it with our Hook 12 ID. Click Save, and then click Run to run the tool. The Depression Identification tool has just finished running, and we can see that the results, a depression feature class, and a depression depth raster, have been added to our map. If we open the attribute table for our depressions by right-clicking and clicking on Attribute Table, we have our standard fields, and then also each depression has its own ID. Each depression also has the percent hydric soil within it, as well as the maximum depth in centimeters. Selecting our depressions feature class in the table of contents, and then clicking on the symbology tab on the right, we open up the symbology window. From the drop-down under primary symbology, click graduated colors. We will be visualizing on the percent hydric field, so we will select that field from the field dropdown. We will leave the method and classes by default, and for color scheme, we will select red, blue, 5 classes. This will give us an idea of where our more hydric soils are concentrated. This can be helpful for understanding which depressions would be more susceptible to flooding and potentially would be worse for farming. We can also symbolize by the maximum depth in centimeters by changing to the max depth in the field. This will identify our deeper depressions and is useful for understanding which depressions may be even more flood prone because water will not be able to easily escape out of those areas. The second output is our depression depth raster. Click on the depth raster in the table of contents on the left and open the symbology window if it's not already open. For color scheme, we will select purple, red, continuous from the dropdown. We will also change the statistics dropdown to DRA. You may need to turn off the depressions in order to see the depression depth raster. This provides a more detailed view as to the elevation throughout the depressions and can be useful for identifying false depressions or better understanding the sloping characteristics of a particular depression. To recap, we ran the depression identification tool and discussed how these can be used to investigate our landscape. In the next video, we will run the next precision conservation practice siting tool, depression drainage area.